All right, welcome everyone to our November Community Power Hour for Black Swan Real Estate. As you all know, I'm Dr. Elaine Stageberg. I have a wonderful guest tonight. I'm so excited to introduce you to. She's going to share with us all about the world of 3D printing of houses, which totally blows my mind. And I'm super excited to share all of that with everyone tonight. Just a couple of quick announcements tonight. For both Fund 1 and Fund 2, we will have a distribution right around the first couple of days of December. So if you do not have your bank account updated in InvestNext, please go in and do that. My Fund 1 folks likely have their bank account updated because we've already done a few distributions in Fund 1, but my Fund 2 folks, you may not have your bank account updated there. So in order to make your direct deposit as seamless as possible, please go into your InvestNext portal, log in, and put in the bank account that you want your direct deposit to go to. If you have any questions, you can email either Rachel or myself. Feel free to go ahead and email me as well, because Rachel's out in Ireland right now. So we want to make sure she has time and space for that awesome trip. But I'll take care of you with the help of our InvestNext support team to make sure that your ACH works perfectly. And we'll do that deposit sometime around the first couple of days of December. So you have a little bit of time, but go ahead and add that to your to-do list to make sure your bank account is up to date. We will have distributions for both Fund 1 and Fund 2. So super excited about that. Lots of folks are asking about when Fund 3 will launch. I wish I knew, and I wish it was right now. We do have everything ready. We have our PPM, our operating agreement, the bank account, everything's ready to go. We're very excited about it. We're working with sellers, we're working with brokers. We're just kind of not getting there, right? Sellers are living in a very different universe in terms of just kind of not believing that interest rates have gone up. So we're still working. There's a few conversations that we're having that maybe look like they're promising, but I've been doing this long enough to know that you just never know, but both ways. Sometimes you'll get a call of a seller that says, yep, I'm ready to go. And other times you think you're getting progress with someone, but for whatever reason, they're just not quite ready to sign that purchase agreement. So no official news for the launch of Fund 3 quite yet. One thing I am super excited to share is the soft launch of my brand new coaching program. I've named it the Freedom and Legacy Blueprint MD program. Super excited about this. I've sent out several emails about it. I've been posting about it on social media. It basically just came from a demand-driven process where a lot of folks have asked me to do coaching, and it seemed like every single day I was turning someone down. And I started to ask myself, what would I tell someone else to do here? How would I coach someone else around this? And I would coach someone else that if the universe is asking you for value, you step up and you deliver that value. So I put together our coaching program. I'm so excited about it. It's a 12-week program. It starts right off the bat with a momentum accelerator, has a core foundational series that's 8 weeks long, a bonus real estate week, a bonus week for relationships. It'll have live coaching throughout, guest coaches, a really supportive Facebook community where I'll personally answer all of the posts in between our calls to make sure people are supported. So just super excited about that. I'll put the link out in our replay email. It's blackswan.mykajabi.com/coaching is our page there where you can learn all about it. Sign up. We're already half full in just a couple of days that we've been soft launched, and I'm going to do our official launch over the next couple of weeks. So if you're interested in that, I encourage you to move forward with enrolling, because once we fill up, we're sincerely, sold out. I'm not going to extend the group because I want to make sure I can really give everyone very focused time during that group. And I don't know if I'll offer it again. And that's not a sales gimmick. It's just that I've not done a coaching program this large before. I want to make sure that I can really deliver. And then I also have a big real estate business to run. So I don't know how this might quite fit into my schedule in the future. So I'm offering it now because a lot of people have asked me for it. And if you're one of those people who has wanted to coach with me, I would love to have you. I'm confident we can deliver extraordinary results for you. So go ahead and sign up if you're interested in that. Those are all of my announcements that I have. So now we turn to introducing our amazing guest this evening. You guys are going to just love hearing from her. This is just such an interesting topic. So this is my friend, Kristen Henry. She is a brilliant woman. She's a Yale graduate. I was chatting with her this morning. As part of her mechanical engineering degree, she created a 3D printer. Like, that takes a lot of brains to create a workable 3D printer. And her love of 3D printing is what led to her eventually working for the company where she is now, SQ4D. She's their chief technology officer. I had the great fortune of meeting her this summer with my women's mastermind in Long Island, New York, and touring one of the very first properties that human beings can live in the United States that's 3D printed. And even as someone who owns a 3D printer, that still like defied the imagination for me. We have a 3D printer that we use to print like little toys for our kids and different things. We use it to print signage. I think I actually have one. I have a couple right here. Not as impressive as the houses that Kristen's printing, but I do have things that we 3D print. So this is what I think when we, do 3D printing. Inevitably in apartment buildings, there's all sorts of places that you need signage that you don't just want, a piece of paper or even a laminated piece of paper. You want something that's nice and classy looking, like please break down all the cardboard, please keep this door closed, those sorts of behavioral things. And so we 3D print these. And this is what I think of when I think of 3D printing. So when I was able to be inside of a physical structure that had been 3D printed, that was just crazy to me. And I knew I had to share this with all of you to, help us be on the cutting edge of real estate. And where is housing going? How is the real estate industry and technology merging together? What does this mean for supply, right? Those of you that come to our talks know that we are in a deep supply crisis in our country because of what happened in 2008. So many builders left the industry and then just never came back. So something like this really has the potential to change supply and affordability and all of those things. What was also so interesting to me is they very much look like normal homes. It took me a while to figure out that it was a 3D printed home. And when I learned exactly how the mechanics of it work, then it like really clicked in my mind how this is, not only a great way to build, but in a lot of ways, a superior way to build. And I'm sure we'll go through that in terms of utility use and insurance because of natural disasters, those sorts of things. And just so excited to introduce her amazing company. I think with that, I'll turn it over. She has a really lovely presentation for us tonight, but then we also do want to make this interactive. So unfortunately, chat is disabled. I'm going to play around with a couple of settings while she's speaking to see if I can get that enabled. In the meantime, please do use the Q&A function. She'll make sure that every question gets addressed. She's done this presentation enough to know kind of the common questions and has wove those answers throughout the presentation. But I know if you guys are anything like me, I had a ton of questions after I had the opportunity to learn about this, and I'm sure you will too. So there's going to be plenty of time at the end to make sure that we get those all addressed. Anything else, Kristen? Otherwise,
I think that was perfect.
The floor is yours.
Amazing.
Take it away, my friend. I'm excited.
Elaine. I appreciate it. Good evening, everybody. Thank you so much for hopping on this webinar. As Elaine mentioned, my name is Kristen Henry, and I'm the Chief Technology Officer here at SQ4D. And I am super excited to talk to you guys today about 3D printing and how it's really revolutionizing the construction industry. So some of the topics I'm going to be covering today are kind of just the current state of housing and the construction industry in general, traditional processes and what you see today. And then I'm going to introduce the 3D printing process and how that all works, comparing it to other methods out there. Then I'll be going through some notable projects in the industry. A bunch of different companies are trying different techniques and focusing on different things. And there's some really cool buildings out there that I'd like to show you guys. Then I'll be going into the machinery and the technology itself to really show you guys and talk through all of the different processes and machines and equipment that go into this whole process. Then I'll just briefly cover the benefits of 3D printing, what this means for real estate, and kind of the future of the industry, what can be expected moving forward. So I'm sure many of you have seen in the news over the last year, the last couple of months, there's a lot of things going wrong right now in the housing industry. Homes are becoming even more affordable, and the price of housing is skyrocketing. and rising month after month. And a lot of that, as Elaine mentioned earlier, is actually due to the shortages in construction, the workforce, as well as supply chain issues and the rising cost of materials. And it's really affecting Americans and the entire world. Even renters are having trouble now paying rent just because of the rising cost of housing. Construction has very much remained the same for hundreds of years. Even today, we still have construction workers climbing up tall ladders to hit small pieces of metal into the side of buildings. There's a lot of lack of safety in the industry and a lot of really antiquated methods that could be using some improvements and disruption. So currently construction, as I mentioned, we're facing that issue with the lack of available and qualified labor. The cost of labor is very high, the cost of insurance and workers' compensation, commodities, supply chain issues, unsafe job conditions, as I just mentioned, environmental issues, and just an overall low build quality. We've seen a lot of really unfortunate natural disasters happening across the country, and a lot of people are losing their homes because of it. However, 3D printing has been used in a lot of different industries lately. We have the medical industry where we're 3D printing tools and parts and even organs out of live tissues, which is super, super cool and exciting. In sports, Wilson actually recently developed an airless basketball. That's all 3D printed, really revolutionizing the sports industry. We have prosthetics, all sorts of cool things being used to revolutionize aerospace, automotive, defense. All of these industries are really taking advantage of this great technology, which allows you to create parts faster and more efficiently. So as Elaine mentioned, she was holding up that sign earlier. Plastic 3D printing is a really common thing out there. I'm sure you guys have seen some of the small scale plastic desktop 3D printers that you can use to 3D print anything from useful parts to Christmas presents to all sorts of things. There's a lot of different options out there with plastic and different types of plastic. There's flexible plastics and hard plastics, structural, all sorts of things. We're even 3D printing metal nowadays. Various parts can be 3D printed out of metal. That industry is really starting to take off. And now we have concrete. So these houses are not created out of metal or plastic, any of those small scale 3D printers, but the principles are really similar. Instead, we're using concrete and laying it down layer by layer, stacking that concrete in order to create a structure. So SQ4D is really hoping to use this concrete 3D printing technology in order to revolutionize the construction industry. Our motto is changing the way the world is built, and we feel very passionately about that, really trying to take this awesome new technology in order to change the way houses are built. Our autonomous robotic construction system, ARCS, is what we use to 3D print structures, and we have been completely self-funded up to this point. So
I'd love to just check in here. I think I have chat enabled, which is why I kind of want to test it too.
Awesome.
I'd love to hear from people. I'm hoping chat works. What is your experience with 3D printers? Do you have one of those plastic 3D printers in your home? Have you seen them? I'd love to get just a little sense from the folks here. What is your experience with 3D printing so far? That'll give us a chance to see if chat is working as well. I believe that I've enabled it.
All right, while you folks are responding to that, I'm going to continue a little bit with the process. So there's a lot of different companies out there that are using different methods that you may or may not have seen in the news. This company, Apis Core, is using robotic arms. So as you can see in that top left picture, certain companies use these robots that have an extending aperture in order to 3D print very circular geometries, and that machine is moved from room to room going around to 3D print the different areas of the house. Then we have prefab 3D printing, where certain companies are actually 3D printing with a UV resin inside of a workshop and then transporting that building to different sites. We have post-gantry systems, where companies are actually using concrete bases to fix their machines to the ground. And then the majority of the industry, which is also what I'm going to be mostly talking about today, is the freestanding gantry system, which is the system that SQ4D, along with many other companies in the industry, use, which is an X, Y, and a Z axis, the three directions on the printer that all work in tandem in order to move around and create the structure. So those towers move back and forth on the tracks, and then the extruder, where the actual concrete is coming out, moves side to side on what's called the gantry, and all three axes move together in order to create whatever shapes and structures you want. So a lot of you probably have not even seen a 3D printer in action up to this point. So I'm going to play this video so you guys can get an idea of the process of building a home with a 3D printer. So to start out, the site prep is the same as traditional. Rough plumbing is installed and then we actually set up the printer on the site according to whatever dimensions are needed in order to print the particular project. And then we can excavate the footings. That's the same as traditional construction. After which we actually print the footings, the printer back and forth here, that is what it looks like to 3D print a house. And there are a lot of different houses out there that have actually already been 3D printed. So in Calverton, New York, SQ4D printed the then largest world's permitted 3D printed home, which was 1,900 square feet, 3-bedroom, 2-bathroom. We have companies that are 3D printing 3-story apartment buildings. This one was built by Cobot out in Germany. SQ4D's Riverhead home was the first home in the world to have 3D printed footings, foundation wall, and slab. That was those subterranean parts you saw earlier in the project, because at SQ4D, we're really focused on 3D printing as much of the house as possible in order to bring as many cost savings as we can to the consumer.
Kristen, can you describe for us what you were narrating during the video? I think there was some audio interference. So we couldn't exactly, hear what you were saying as you were going through, but could we go back one slide and then maybe you can describe, people have seen the video now, so that's in their recent memory, but can you walk through what you were narrating there of, how you set the machine, how you work around the electrical boxes, how you have the template, all of that?
Yes. Thank you for bringing that to my attention. So
absolutely.
SQ4D, we're 3D printing starting subterranean. So we 3D print that foundation in order to have a nice level surface to print off of. Can start to print the foundation walls, go ahead and backfill the slab, self-leveling as we go. And encased in the slab is conduit so that we can run electric after the fact. So that's really nice because then the conduit is actually entombed in the slab, making it fireproof, which is super exciting and a very helpful additional safety in the process. Then we keep 3D printing the house until we get to different checkpoints, one of which is slicing for electrical boxes in order to put that in all the outlet locations, after which we can just keep 3D printing over them until we get to the light switch height and countertop height for various appliances. Then we add those electrical boxes in. Keep on printing until we get to the rough openings, the doors and windows, the top of those, we just conventionally frame out and then can 3D print right over top of it and keep going. So all of the processes are really integrated into the actual build. There's really no downtime or stopping. It's all just continuous in order to keep printing the house. Here's another example of a cool project going on. There's a company that's 3D printing a development out in Texas, which is super great because then you can keep moving the machine line to line and create a lot of these great structures to create an affordable community. And this was another project that SQ4D recently did, where we're actually serving as the subcontractors in order to 3D print that main structure, that builder shell of the wall, as I had just mentioned. And then we also have companies out there that are working on making the process as eco-friendly as possible. So the University of Maine recently created a 3D printed home that is using fully recycled materials. So that's super exciting in light of kind of changing climate and all of the environmental considerations that we need to take into account. 3D printing is answering that call. So in order to create those houses, we actually only need 4 pieces of equipment or machinery on the site. We have the 3D printer, a cement silo, a mixer, and a pump. So these machines all work together in order to create the concrete that is actually used to build that home layer by layer, as you just saw. So that cement silo over here in this picture on the left puts cement into our mixer, which is then mixed with sand, Portland cement, and water, which then goes into our pump, is pumped through hosing to the printer, and then is extruded, as you saw in all those videos earlier. That's compared to a traditional construction site. This is just an example of something you might see in the city, a concrete building being constructed where you have cranes and all sorts of material that you have to account for and cut and worry about different dimensions and such. What's really nice with concrete 3D printing is we know exactly how much concrete we need, and we make the appropriate amount as we go. So that's all the hardware that's involved. As far as software goes, so you guys can get a better idea of that. The traditional house plans that architects made, the 2D drawings, we take those, we turn them into a 3D model, as you can see here below. And then we use what's called slicing software in order to convert that model into code. So it's called slicing software because it takes that model and layer by layer looks at the pattern and all of the turns and rooms and everything that's involved in that certain layer, that certain slice. And it takes that and gives the instructions to the printer to follow, which is then called G-code. So then the printer follows that code according to those plans from the architect. What's really nice about that is there's really no room for human error. The plans are copied directly into that 3D model, and then the machine just follows the instructions accordingly. So in that video, you saw a rectangular nozzle that rotates along corners. So something that's really exciting about the 3D printing industry is that the different nozzles can have kind of different effects on what the final product looks like. So SQ4D uses a rectangular nozzle that tangentially rotates when turning corners in order to result in better stackability. And you can kind of see it's more of a uniform look along the side. But other companies in the industry are using different methods. So some companies use a scraping arm bead in order to kind of take that circular bead and flatten it out along the edge as they go. And then some companies use a circular bead that results in a different looking geometry. So if you can kind of imagine, the circular bead is sort of like taking 2 tennis balls and smushing them and stacking them so you have a little bit of a rounded edge as you go, which leads to a different looking aesthetic versus that scrape bead versus a rectangular bead, which results in layers that look like that. So at SQ4D, we're using Portland cement, sand, and water. That's it. In order to create the concrete, it's very much readily available traditional materials that you would expect. Some other companies in the industry are using things called geopolymers, admixtures, accelerators, plasticizers, chemicals, all sorts of things in order to create a 3D printable mix that works with their machines. So overall, it's called concrete 3D printing in general, but there are certain companies that are actually not even using concrete, but rather various clays or geopolymers or other materials. As I mentioned, SQ4D is one of the companies that is 3D printing subterranean as well. We really believe that in order to optimize as much of the building process as possible, we really need to be printing a great percentage of the house. That's really what's going to lead to the most cost and time savings, rather than bringing in concrete trucks into small, difficult to get into areas. We just use our mixer on site in order to self-level and create the slab, as well as all the interior and exterior walls above the surface. So this chart just kind of shows a landscape of all the different companies out there that are using these various systems, as I walked through before, including robotic arms, gantry and post gantry, rectangular versus circular arms. And a lot of different companies are actually using their proprietary mixes as part of their business plan. So a lot of them sell the mix with their machine as sort of a revenue for the company. And you need to use a specific mix with their machine in order to get it work accordingly. SQ4D is using locally available materials, as I mentioned, that Portland cement, sand, and water. As you can see, there's not a ton of houses out there actually that companies have sold. So Icon with that community has a bunch of sales pending. At SQ4D, we sold 2 of our homes. But you can really expect these numbers to increase dramatically in the next couple of years as 3D printing takes off. Some of the benefits of 3D printing and construction in general, I'm sure you guys have heard this one before, is speed. So 3D printing in general is known as rapid prototyping for smaller plastic projects and such, because people are able to very quickly create parts and use them for various things. So what's really nice in 3D printing and construction is that there's really no downtime. We integrate the plumbing and electric and various processes into the actual print schedule in order to keep stacking concrete and keep creating the house. In 3D printing, concrete, it's actually called a cold joint if you wait too long between layers and have the concrete set up. So in order to avoid that, you really want to keep the process moving and have absolutely no downtime and keep stacking layers as you go. Strength is another really big thing. A lot of people don't know that we actually use quite a bit of reinforcement inside of the already very strong concrete walls. In our last 3D printed house, these are actually lab results you have here on your left. We are having kind of an average close to 9,000 PSI compressive strength, which is incredibly strong for homes. 3,500 is what's required in the area. So these homes far exceed compressive strength required, and then are also rebar reinforced with horizontal and vertical support columns. So this house is really not going anywhere. As I mentioned, in light of increasing natural disasters, the homes are really wind, flood, fire, and pest resistant. So these homes are really built to last and to stand up to a lot of these disasters that are going on. Cost is another big thing. By nature of quicker projects, you have less carrying costs because of less build times, but also there's just a lot less workers and liability on the site, which is very helpful in light of the difficulties that the construction industry is having in terms of labor shortages. And then materials are another huge thing. In Long Island in 2021 and 2022, the price of a 2x4 actually reached $14.65 at one point, which is just absolutely ridiculous due to supply chain crunches. That price really fluctuated and was driven way up. I mean, people used to go get 2x4s in order to have a fire pit in the backyard because it was less expensive than getting wood, which is crazy because we really jumped through the roof on 2x4s. Concrete is pretty consistent and is not as subject to those supply chain issues and fluctuations. Worker safety, another thing I've already touched upon. By automating construction, it is far safer for workers. You don't have workers climbing up tall ladders or walking across roof struts or really doing any of the things that contribute to OSHA's Fatal 4. Faults, trips, and slips accounted for 37% of fatalities in construction in this past year, which is more than all the other sectors of the workforce combined. So construction is really dangerous, which is also contributing to not as many people wanting to work in the field, leading to shortages. So automating things is just inherently safer. Now, here's a comparison between a traditional wall section versus a 3D printed wall section. So in traditional, as I already touched on as well, you have many, many materials. You have sheetrock, studs, plywood, vapor barriers, tape, other barriers and siding. You have vinyl siding on top of all your structures. With concrete 3D printed houses, you have concrete, insulation in the void, and those structural supports I was talking about. So it is a lot less waste inherently, because rather than cutting all of these materials that then oftentimes go to the landfill, we know exactly how much material we need and can use it. More than 75% of construction waste on traditional sites actually ends up in the landfill, because things like wood, drywall, asphalt, shingles, bricks, all that really can't be reused or recycled. Concrete can actually be recycled into RCA, recycled concrete aggregate. Insulation is really flexible as well, which is super exciting. In traditional construction, you have a 2x4 and you can fit 4 inches of insulation. If you want additional insulation, you need to go to a 2x6, 2x8, 2x10, etc. And costs increase dramatically with that. With 3D printing, you can place one bead anywhere and then the next bead as far apart as you want in order to reach the desired R value for the home. So that's super exciting in areas that suffer from difficult climates and things. There's really no cost to the builder to increase aside from a little extra insulation that's going to lead to really substantial heating and cooling cost savings. This is an area that I know a lot of you are really excited about, is just the cost of 3D printing and what some of the numbers look like. So SQ4D recently sold one of our houses in Islandia, New York that we printed, and it sold on the open market for $550,000, which was 10% over the $500,000 asking price. And it's really exciting because builders can tap into unprecedented margins. That house was profitable, and the homeowner is already seeing equity increases in the home. And along with that, the insurance costs are much, much lower for the home builder, which a lot of people don't think about. Since there's such a high fire rating and easy flood remediation, we are able to save homeowners a lot of money on their home insurance. For example, our 3D printed home in Riverhead, we were paying $658 a year for insurance, as compared to well over $2,000 a year for insurance for a regular home. And along with this just goes the very little repair needed on rentals. So nobody's going to open a door too hard and put a hole in a concrete wall as you might with sheetrock. Subcontractor building is also another really cool area. SQ4D served as a subcontractor on our most recent home. And we charge $50 a square foot for the printed home. And in the next couple of months, we're going to be printing with Habitat for Humanity, who has signed a contract for $99 a square foot, which we expect to be profitable and still deliver a less expensive home than traditional construction would. So it's really an all-around win. Owning a machine is really the best way in order to capitalize on all these things. The approximate cost to build in Long Island, New York is very, very high. With 3D printed construction, builders can expect around $100 to $120 a square foot for base construction. And then traditional is 2.5 times that generally. And comparable concrete masonry unit or cinder blocks, as you can expect and probably have seen before, building like that in order to create a comparable strength structure is around $300 a square foot. So that brings me into kind of where you can expect this industry to go. So currently we're 3D printing houses, but in the near future, we plan to print commercial buildings and infrastructure. If we're able to make a difference 3D printing houses, just imagine repaving giant roads across the country. We're really going to be able to use the technology to the fullest, and then also there are some really exciting material considerations coming up with the sequestration of carbon and the addition of glass as a partial or full replacement for sand or other aggregate in the mix in order to take materials otherwise destined for the landfill out of the environment and start to actually put them in the homes. There are other companies that are also working on putting plastic as aggregate in the mix in order to keep that as well out of the environment and use it in a useful way. Within the industry, there's a lot of different options that different companies are taking advantage of. Different companies can sell machines, sell the homes, service subcontractors, rent the homes. There's joint ventures, licensing, service and repairs, consulting. There's really a lot of great things happening in this industry and a lot of different ways people are taking advantage of it. So you may see ads for 3D printers, construction 3D printers being sold in the near future, as well as these homes really popping up in a lot of different areas across the country. Thank you guys so much for listening. If you're excited about this and want to see some more videos, please check out any of our social media pages: Instagram, Facebook, LinkedIn, YouTube, TikTok. I put my personal email there if you guys want to reach out with questions if they're not answered after this, as well as info@SQ4D, our main informational email. And that's a QR code if you guys are really excited about this technology and want to sign up to learn more and see about potential investment opportunities. Now I'd be super happy to answer some questions.
That is so neat. I love seeing the machine. I love seeing the actual house that you and I were in together. That's pretty cool. It was like, I forgot that it was like, you guys had like pulled out all the stops to get us in there. I think they delayed closing a few days or something. I forgot about that. Yeah. There's just so much that you described, when we were there, around insurance costs and utility costs and repair costs. And, I hadn't even thought about as a potential rental, the number one cost for turnover is patching nail holes and repainting, because things just never look good until you repaint at least that whole wall. You can't really just kind of paint a little bit, but you wouldn't have that in these properties. And there's just so many ways that this is just so fascinating. We have a couple of questions that were put into Q&A. I did finally get chat to work, so I'm excited about that. So I'll read out the questions that were already in Q&A, and then feel free to put more into chat if you guys have any. I know I had a couple, and I'll go through those with Kristen so that she can answer them again. Someone asked, what is the cost per square foot to build? I think you touched on that a few slides ago.
Yes, I did. So it's around 100 to 120 all in for base construction. So that's including things like a concrete polished floor and such. If you want to increase from there, obviously that's additional costs. But what's really nice and what allows us to get those savings is the reduction of general materials. So there's no vinyl siding needed on the outside. There's no sheetrock. Kind of the structure of the home, and the important part is also the aesthetics of the home. So this is something I actually didn't even touch upon. You can actually keep these accented layer lines, as you see in this bathroom picture here, or you can smooth out the walls to kind of give it a stucco finish like you see in this Riverhead home to the left. So there are a lot of different options. No need for sheetrock or any other structures on top of it. The concrete does the work.
Like when you say those numbers, I remember the very first home that I owned was a home that I built in Oklahoma City in 2009, and it was just a starter home, and I built it for around 100 per square foot, and that's what, 14 years ago, 15 years ago, and in a very low cost of living area where there, at that time there was plentiful labor. That was during the boom of the housing market. Like, it's crazy that you're able to replicate those numbers in a completely different part of the country where things are much more expensive, a decade and a half later. That's, wow, my mind is blown.
Yeah, that's some really great context, because just to mention again, we're in Long Island, New York, which is arguably one of the worst places to build, just because a lot of the material has to get shipped in across bridges, and it's just difficult to get all the supplies and workforce you need, and the cost of things in general in New York State are super high. And there's a lot of regulations, but that's kind of why we chose to build here, because if we can build here, we can pretty much build anywhere across the country.
I love it. That fits so much with one of the core tenets that we believe at Black Swan, which is the obstacle is the way. That when you're climbing that mountain, there are times when you're like, why am I doing this? Why did I pick such a tough mountain? But when you get to the other side of the mountain, you not only can you climb that mountain, but you're ahead of all of the folks who chose not to climb that mountain. And then all of the other mountains that are smaller just look like nothing. So I love that you chose to build the business there so that when you go to other places in the country, it's just easy peasy. Not only is the technology going to be better and the company will be better, but you'll have, easier regulation, all sorts of things. Another question, lots of great questions, guys. Keep them coming. Are concrete homes allowed in markets like California where earthquakes are an issue?
Yeah, so there are some 3D printed houses out in California. And what's really, really nice about these homes is that they're completely customizable in order to fit with building codes. So in areas where you can expect earthquakes or other natural disasters, you can actually increase the amount of support and strength of the structure. So if you are looking for a stronger overall home, you can use more rebar supports, you can have more vertical structural support columns, change what the pattern looks like inside of the walls, much like traditional 3D printing plastics. If any of you are familiar, you can change the infill, which is kind of the inner strength of the structure. We can do that same thing here with 3D printed housing. So in a place like California, we would use quite a bit more rebar in order to provide that shear and tensile force, as well as the high compressive strength of the concrete.
I remember when you were describing to me that structures in Europe have been built with concrete for like literally centuries longer. And that like really helped it click in my mind that, oh yeah, like we're so acclimated to sheetrock that it seems like it's this really wonderful material. But in reality, it's not. It's like it's literally like powder that's compressed.
Yes, that is such a great point. Yeah, across the world, most places would be super confused to hear the idea of a stick-built structure with 2x4s and wood. Really, in America, we got here and there were a bunch of trees, so we had to figure out a way to use them. But that's really not the case for the rest of the world. So that's been interesting as well, seeing people kind of get more accustomed to these concrete structures here in America, where most people are used to the wooden structures that we build currently.
Is the United States behind the world in terms of 3D printing because of that?
I would say not, just because a lot of the kind of leaders in the industry have formed companies here in the United States. There's even a couple companies that have moved to have headquarters in the United States. So I think that's kind of what's put us ahead in terms of technology and development, but just general acceptance, people are still getting used to 3D printing. But as Elaine mentioned, they really look quite similar to a traditional house. If you look at this building here with the wood floors and the smooth walls, it's really not until you see those layer lines that you know it's 3D printed.
Yeah, I agree. When I first saw it, I mean, and of course I knew I was walking into a 3D printed home, but when I first saw it, it just looked like a design choice. Yeah, maybe a little bit of an interesting design choice, but I've seen lots of interesting design choices in real estate. And I think particularly in high-end real estate, there's more of a call for kind of those interesting design choices. So it didn't stand out to me as odd or unsightly or unattractive or anything. I think if anything, it was kind of a neat talking point that, if you scroll back however many slides it was to that home that I was in, from the street, it just looks like a normal, white, nice home. But then, when your friends come in, you might be able to say like, look, my home was 3D printed. Do you see the layers here?
There we go. Yeah, exactly.
There it is. That was the one. That was the one I was in. So yeah, from the outside, it looks, just totally normal. And then on the inside, it looks very normal too. But when you're, if you're up against the walls, it's a talking feature of like, yeah, my home was 3D printed and here's how, and it's so cool. Clearly I'm very interested in this. Victoria has another question. How difficult are these homes to renovate or reconfigure, such as moving doors, windows, or walls in the future?
That's a really great question. So with 3D printed structures, you actually are able to move around some of the load-bearing interior walls. Obviously, knocking down concrete is not as easy as moving 2x4s and such. So it is a little more difficult to renovate, but that's at the expense of a home that's really built to last and is kind of indestructible. So there is a possibility. You could certainly wood frame walls after the fact as well if you wanted to split up rooms and add some different aesthetics to it. So there is possibility, but for the most part, we advise kind of against that. We actually warranty our homes for 50 years. We have a 50-year warranty on these structures, which is just unheard of. Because we believe so strongly.
To put that into perspective, folks, in Minnesota, a warranty is a year.
Yeah.
For stick built, like a year, like that's a long time.
Yep. Yeah. So we really believe these structures are built to last, and that's kind of the goal of them. So though you can do renovations, for the most part, really, it's going to be a generational home that's passed down throughout the family for years and years and years.
I like the idea of, potentially, particularly in like the living area, maybe putting in less walls. And then as trends change, because inevitably the open kitchen is going to go away and those sorts of things. It's like hard for us to imagine, but fashion always, reverts to the older style.
Exactly.
You can add that, that traditional wall kind of to split up the living area and then kind of be able to take that out every 25 years as traditions change, but your general structure is there. Some excellent questions. How much does a machine cost?
Yes, so we are currently selling our whole system for $750,000. So that includes that volumetric mixer I mentioned, the printer, the pump, and the silo. So you don't need to get all of these parts, but all in, that's the whole price. And the printer itself is actually just under $400,000, which is super exciting because we're really trying to make this something that people can really enter into and start to reap the cost savings from this technology. So in context, $400,000 is really not that much for a piece of construction machinery. I mean, people are paying half that price for large excavators and other machines to move equipment around. So at SQ4D, we're really trying to lower the barrier of entry so that people can enter this field and start building and seeing profits pretty quickly. Different companies across the sector are selling it for different amounts. A lot of machines hover for around $1 million. So we're a bit under that.
Wow. When the ground shifts, will the walls crack?
Great question. That's somebody who understands concrete. So in general, concrete cracks. That's if it's not cracking, then it's probably not true concrete. Since we take so much care to hydrate the walls throughout the process and such, we never really get anything more than hairline cracks, which are just tiny little cracks in the structure that you can rub some epoxy on top of, or even paint with elastomeric paint over. So really, you'll see the formation of a couple cracks here and there on certain walls. Really, that first freeze and thaw of the season when the ground's moving, but after that, there's really no introduction of additional ones.
What would your plan be if a home did have substantial cracks?
So yeah, that's part of our warranty. Actually, we agree to come in and assess the cracks and either address them structurally or just do the small remediations I mentioned with just some epoxy or paint over the top, as long as it's not structural.
Interesting. One of the things that was interesting, I think because we're in Rochester, Minnesota and Tacoma, Washington, both are moderate regulatory environments, and we do new construction here in Rochester, and we do a lot of renovation in both of those markets. And so we know the whole, permitting and building process. And I mean, that is often like the bulk of the time and expense is just getting the city to agree that you can build a structure. And I'd love for you to share the story of how you guys built that first house and kind of negotiated with the city that no one would live in it. I just thought that was so brilliant. It's an example, at Black Swan, we talk about playing the infinite game. And you don't play the game to win the game, you play the game so that you can stay in the game and keep playing the game. And to me, that was such an example of playing the infinite game with the company, with the technology, with the city, to say, you know, we might lose this tiny little battle here with this one property, but it's going to allow us to win the game. I'd love for you to share that story for people about, you know, kind of thinking about, because I'm sure, you know, I can see a city council member thinking, well, what if it cracks? What if it falls down on someone, right? And how do you educate those people to get, you know, to be allowed to build this way? I'd love for you to share that story.
Certainly, yeah. So back in 2019, 2020, when we built that first house, obviously building departments weren't super familiar with the process. We went in and we're kind of like, all right, so we're going to 3D print a house with a robot out of concrete. And building departments were like, wait, what? What now? What are you doing here?
Building departments are not typically known as the most innovative
no,
group of folks.
not the most forward thinking on top of things. Just in general, the construction industry is pretty stagnant. So not a lot of changes have been seen. So a lot of building departments aren't really used to people coming up and saying that they're going to completely build something in a new and different way. And there are no regulations out there yet for 3D printing. That's still a process that nationally is being addressed. But SQ4D decided that we were going to 3D print a demo house in Calverton, New York, that we were going to have permitted and be a livable structure, but we agreed with the town that we weren't going to have anybody live in it. This was just going to be our demo house to really prove how the technology works. We had the building department there kind of the whole time overseeing the process, took very thorough videos, showed how everything worked, and it's still standing there in great shape today. And it's great because we can really show building departments this technology makes sense. It was efficient. This structure is super strong. We actually have done videos at that house where we have put flamethrowers to walls and have driven trucks into the side of it and have bashed it with a hammer and nothing.
Like a super boring tour. I didn't get to do any of that.
Yeah, it could be fun. Yes, so definitely check out YouTube and see some of those videos just to see how strong the structures are. And the other note I have as well on the crack propagation that person asked, we actually do also include expansion joints in our structure, which allows for that movement and shifting of the concrete without compromising the structure.
Wow. How can someone get a home built with you?
Great question. So as I mentioned, we're currently in the midst of our capital raise, and we're really looking to scale the company so that we can take on projects like that. Up to this point, we've really only done specific projects with either chosen partners that we can do joint ventures or subcontract on, or have just bought the land and done the whole process ourselves. But the goal is in the future for us to be able to get a call from somebody, say, hey, I have this plot of land, here's what I want my house to look like. We throw those 2D plans into our slicing software, can come 3D print them a house and pass along some of those cost savings. Because as I mentioned in that one slide, the houses have sold over asking price every time. So the first house we tried to sell in Riverhead, we actually listed at $299 and got offers as high as $550,000, which, you know, it's just the market dictates the price. So within the next couple of years, we really hope to move towards a model where we're able to do that. We're not able to until we scale up and continue building these machines and sell them to other builders as well, so that process is possible.
Yeah, several of you have had all sorts of different questions around JVs, investing, those sorts of things. So on the very last slide, maybe you can scroll back to that one. That's her email, the company's email, lots of different ways to contact her. So definitely reach out if you're interested in learning about various investment opportunities there. Another interesting question. I really like this question because it has me thinking about what we might be able to do at Black Swan. Can you rent the machine? Can someone rent the machine to build a structure?
That's a great question as well. A lot of different companies in the industry have actually chosen to go that route, renting the machines to different people. And one of the biggest advocates and players in that market is actually universities. Universities are super excited to rent the machines for different projects and things and such. At SQ4D, we're actually focused mostly on selling the machines and actually printing the projects. Just because we really believe that people should learn how to use this technology and really get to take advantage of it and grow with it and learn things. There's really not too high of a learning curve, but things like architectural plans and such, people aren't super familiar with all of the capabilities of 3D printing yet. So it's kind of a waste to do one project without really learning all the advantages you can get out of this process, whether that's putting in curved walls, or different design patterns, printing fireplaces, printing islands in place. A lot of these things are just not possible with traditional methods, so people aren't super familiar with them. So that's why we're looking to sell machines to get people really invested and being able to make profits as they continue to learn the process and get really good at creating structures.
Do you see your company supporting, it's going to have to be like a pretty entrepreneurial builder that's going to, take the risk and the initiative to buy a machine like this. Do you see your company supporting that person with getting like the regulation and everything approved in their own local, with their own building and zoning department?
Oh, definitely. Yeah. And really building and zoning has been so much less of an issue now that 3D printing is more familiar and a lot of people have heard of it. It was really the first couple houses where building departments were kind of confused and not really sure what was happening. But here on Long Island, we actually now have towns and administrators asking for us to come build in their area. People are willing to donate land and all sorts of materials and such so that we can bring 3D printing. So there's really a lot of widespread enthusiasm now. But as part of our success-based model with 3D printing the machine, with partnering with people who are looking to 3D print projects, we actually, part of our service contract, commits us to helping that builder and making sure they can build as much as they can, rather than other companies who are having builders pay for their specific material, which kind of leads to the more you mess up, actually, the more money those companies make because you have to waste material and start projects over and such. Ours is completely success-based. We get a fee based on how much you are able to print throughout the year. So that means we're completely dedicated to making sure that the builder can produce as many homes as possible. So wow. For a $5 per square foot fee in perpetuity on these machines, we help the builder with lifetime builds throughout the entire lifetime of their machine, which is expected to be very long. And for that, we offer constant support and help out with the slicing and production of models so that they can print as seamlessly as possible.
Wow. I love that alignment of interests and alignment of incentives there. That's so critical when two companies are doing business together. Wow. I knew I liked you, but like just the more you talk, the more I like you. Okay, so those are all of our questions that people put in the Q&A section. Now let me hop over to the chat section. I move people over to there. I appreciate everyone's patience as I navigate the world without Rachel. Are there any temperature limitations on the construction in either hot or cold temps?
Great question. So we generally try to print anywhere between 28 degrees Fahrenheit up to about 100 degrees Fahrenheit. Below 28 degrees, you have obviously water freezes below that, and water is 1/3 of the materials we're using in this process. So there are ways around that. You can heat the water, you can put blankets over the concrete at night to help out and make sure it cures properly. But really we try to print at temperatures that are mostly over that lower threshold. And then over 100 degrees, you actually have the concrete curing too quickly. So water evaporates really quickly, and part of the process of hydration, where the cement actually cures and strengthens as it forms the strong concrete that with those strong compressive results. If you rush that process, it actually does not cure properly. So you just have to be really, really good about hydration. But there was actually a project out in Dubai that happened a couple of years ago. And I saw pictures on the site where they actually had ice packs on the motors and on the water lines, and all sorts of things, because everything was overheating because concrete actually creates heat as it cures. So over that temperature, it's kind of difficult just to make sure that you're getting that proper hydration and curing process. And then below 28, you really have to worry about water freezing. But other than that, we're able to print in rain and snow and all sorts of conditions, as long as nothing is severe enough to dent the actual concrete. it's curing and setting up.
Interesting. I could see how, because there's so few workers on site and it's so safe because you don't have people on, scaffolding and that sort of stuff. In areas where it is over 100, you could print at night. You could print in the dark when the temperature drops, because there's just not those safety concerns.
Exactly. Yeah. And that's a really great point. The sun really affects the curing of the concrete too. So at night, even if the temperatures are higher, you don't have to worry about that water evaporating as quickly. So that's a really great point. I didn't mention these machines overall are really quiet. So we actually have printed into the night, even in neighborhoods. Really the loudest part of the process is power washing to clean out after the fact.
Wow. Does the price include interior for kitchen and bathrooms?
Yeah, so that 100 to 120 that I mentioned is the base cost to build, including all of the finishing you would do interior to the house. So that's why those numbers as subcontractors that I was reporting was to build the main structure. But a lot of your costs for building actually come in with the electric. So electric is a lot more expensive than people realize. That accounts for about $20,000 or more of the build. So that price I reported is all in finishing at just a kind of a base model.
Wow. If cost is less and time is quicker, what are the downsides to 3D printing?
That's another great question. So really the main things currently are just kind of acceptance. People are still becoming more familiar with it and learning, and a lot of people and building departments still just need to figure out all of the different possibilities in the field. So that's really the main thing, is that people are not super familiar and there's no building regulations, as I mentioned. That's starting to be developed. There are starting to be codes, and even things like lending on homes is starting to become a thing. There is some very big lenders out there who recently announced policies on 3D printed homes, which is certainly a step in the right direction. Some of the really big names out there are starting to create policies. So that's really the main thing, is that people are not familiar and there aren't a ton of policies and procedures in place yet. But other than that, as I mentioned, renovations are a little bit tricky, but for the most part, you're able to add, and then as long as it's not load bearing, you can subtract. It's just concrete. Concrete is difficult to move and cut through.
I think something that was really probably like the most pivotal thing for me, seeing all of this, is the software is quite an innovation, but really at the end of the day, a concrete structure is like more timeless than a sticks and bricks structure. So it's actually like less innovative than it seems, in a good way, right? Like it's not a house made of a material that like was just created by scientists 5 years ago that like we don't really understand. How does that material age? How does that, material handle extremes? Like there are parts of the process that are incredibly innovative, but there are parts of the process that are very, very old and very, very timeless. And it, like this picture is such a good example that like a human could have laid that. It just would have taken 1,000x amount of time and wouldn't have looked nice, and all the additional costs and complexities. But a human could have done this. If we just decided, we're going to build with concrete in our country. It's really the machine that's quite innovative, but the actual house itself is very timeless.
That is such a great point. Yes, exactly. I mean, concrete is pretty much the second most studied material aside from water.
Oh, really?
We've had it for forever, and it has been used and studied. I mean, we still have structures that the Romans built X amount of years ago that are standing strong. So we're very optimistic that our concrete structures will outlive any of the traditionally built ones today.
Wow, very interesting. Couple of last questions. If anyone has any additional questions, now's your time to pop that into chat. How do you fix plumbing issues if the concrete is covering it?
Great question. So we actually have access panels throughout the walls. I didn't have any pictures showing that, but in all the areas where we have wet walls with plumbing and such, we account for access panels within those walls so that you can still get to any of the plumbing. And then similarly with electric, everything gets snaked through that conduit. So if you do have a problem with the wiring after the fact, you can just snake it out of the conduit, fix it, and then vacuum snake it back through. So we leave that conduit, so that's all accessible. And then similarly with the plumbing, you're still able to get to it after the fact.
You just build like a recess in the 3D plan.
Exactly. Yep.
Yeah. Interesting. How many houses have been built with 3D printed technology in the United States or in the world?
Great question. So we have really less than a dozen that have been permitted, but there's far more than that have been built. So there's a lot of universities and companies and places throughout the world that are building structures, but not all of the structures are really livable and permitted and focused on being homes for people. Some are kind of experimental, some are kind of artistic. So overall, there's probably a few dozen houses and structures that have been printed, and then of that, really SQ4D has 2 that have been permitted and people are actually living in. And then similarly, one of our competitors, Icon, who just 3D printed that subdivision, is starting to have families move into their homes as well and actually live in them. So it's interesting because there are also projects in Africa and such where people are focusing on using found materials in the areas to create like little huts and things like out of clay. Some people are trying to build schools out of various materials in these areas where it's hard to access kind of conventional materials. So really there's a ton out there, and people are working on making it more and more of an actual structure that people want to live in.
I thought it was just so neat this summer when you told me how few homes there were, because once I was standing in one, it was just so obvious to me that it would be a great way to solve the supply problem that we have. And, because I'm an entrepreneur, I'm like, oh, innovation. Oh, let's get, the cities to approve it, insurance companies to insure them, and lenders. Like it just makes perfect sense once you're standing in it, that there's real value here. And again, it's not this like crazy material that's never been, it's just the way the material's laid. That's really the innovation. And that's why I wanted this webinar. So I'm just so appreciative that you were willing to come and speak to the audience, because there's so few of them, but we're at this inflection point, I believe, that, 2 years from now, this is going to be like old news. Like they will be everywhere when cities figure them out and builders figure them out, and just people figure out that this is going to be a big part of solving the supply problem in our country.
Exactly. And I'm so thankful that you gave me this opportunity to talk and educated on it as well. Just because exactly as you mentioned, companies are really starting to move past the R&D phase now that this has been proven out, and actual homes are built that people live in, which is super exciting. And it's all been very positive and going well. So companies are now starting to scale up and create more and more of these. So you guys will start to see them popping up all over the country.
Absolutely. Well, no one has popped any questions in for the last minute or two, so I'm going to assume that between your presentation, our dialogue, and the questions, that everyone had an opportunity to have their questions answered. Again, thank you so much for your generous time of not only, hosting us this summer. That was kind of the start of all of this, but also coming and doing this virtually, to share it with our audience. I'm so grateful to you for that. If anyone wants to grab her contact information, please do that. I will also have it sent out in the replay email that goes out tomorrow, so you'll have an opportunity to grab it in that email as well. If you're interested in talking with her about potential investment opportunities, please just reach out to her directly. I know there's lots of great opportunities. They're doing their first raise, lots of ways to work together. So excited. Had a really wonderful time tonight. I hope you all have had your mind blown as much as I have. Just like Nick joined the call. He's in Austin, Texas tonight. And I'm sure he and I are going to have like a post-call call talking about this. And like, is there a way to bring this to Rochester? Like, how do we make something happen with this? Because I really think it's the future. So with that, we'll call it a night tonight. Thank you so much, everyone. Thank you, Kristen. Super grateful for you, and everyone have a great night.
Thank you so much.
Absolutely. Good night, everyone.